A 100-meter long train is moving with uniform velocity of 45 km per hour. The time taken by the train to cross a bridge of length 1 kilometer is. It would be better if you try to visualize the question first. So let us take two conditions. So right before crossing the train, before crossing the bridge, and after crossing the bridge. So let us say this is the bridge, okay, and this is the road or the rail. This is the rail. And the train is, I'm not going to take the exact values here. Let me just write length of, it says train, right? So length of train is, say, LT. LT is length of train, okay? And what is this much distance? It is length of bridge, say LB. Okay, now what happens after crossing is, I think to make more sense, should make a small rearrangement here. See, right before the train has started to cross, right, this is how the train would look like. So this is length of train. Now after crossing, what happens is, after crossing, the train has completely moved over the bridge, right? The completely train has moved over the bridge. So it was earlier here. It slowly moved like this, and then it's covered the entire bridge. Now, how much is this distance? This is length of the bridge. And how much is this distance? It is length of the train, right? So the train was in this position when it has passed the bridge, or when it has crossed the bridge. It is not the initial, initial line that it should pass. The train should pass. Okay, let me make a reference here so the things will become more clear. So if you say bridge is B1, B2, and train is T1 and T2, okay, T1 and T2, only when the T2 portion coincides with the B2 portions, or do I choose a better naming? That would be fine, right? Okay. Oh, that's the name. Okay. So when the final portion of the train, which is T2, coincides with the final portion of the bridge here, which is B2, only then the crossing is complete, right? So crossing completes when T2 overlaps with B2, which happens in this case. When T2 overlaps with B2, what we get is a straight line, B1, B2, T2, T1, T2, right? B1, B2, T1, T2. So the whole distance becomes B1 to T2. So the whole distance B1 to B2 can be written, or can be drawn as like this. Can be drawn as, right? So this is length of bridge and this is length of train. In which case, what is distance traveled by the train? In which case, distance traveled by the train would be equal to LB plus LT, right? So I'll write it as S of T is equal to LB plus LT. What is LB? This length of bridge is given to be 1 kilometer. Okay, units are not matching, so let us use, since it is second, we'll convert all to meter per second. So let us make 1 kilometer. So it is given to be 1 kilometer plus what is length of train? Train is given to be 100 meter. So distance traveled by the train is 1 kilometer, which is 1000 meter plus 100 meter. So length traveled by train is 1100 meter. Now, if that is the case, what is the velocity given? Velocity of the train is given to be 45 kilometer per hour, right? And what is 1 kilometer? 1 kilometer is 1000 meter. What is 1 hour in terms of seconds? It is 3600 seconds. So velocity of train basically becomes 45 into 0 and 0 will cancel. So 45 into 5 by 18, right? Which is 5 5s are 25, 5 4s are 20 plus 2 is 22. So we get 225 by 18. So velocity is 225 by 18, 225 by 18 meter per second. Now what is that we are supposed to find out is the time taken. See, so time taken would be equal to distance by speed. What is distance? Distance is st. What is speed? Speed is vt. So st is 1100 whole upon speed is 225 upon 18. So this becomes 1100 into 18 the whole upon 225, right? Which is equal to, so if we write down the numerical once again, so 1100 into 18 by 225, right? Okay, so 9 2s are 18, 9 4s are no 9 2s are 18, 22 minus 8 is 4, rest is 5, 45, 9 5s are 45, so 2 by 25. So 1100 by 25. So this becomes 5. 5 2s are 10. 5 2s are 10. So this becomes 220. Right. So 220 by 5 is 5 4s are 20. 20. 5 4s are 20. So 44 into 2 now becomes 88, which means the correct option is 88 second, option C. And I think I should add one more point here. See, that was not, I think the diagram was a bit confusing, so I would like to rephrase the diagram. So it goes like this. This is the train, right? And let's assume this to be the bridge. Okay, train and bridge. So this is the point of initiation of crossing, right? So after crossing, what happens is the bridge is stationary, but the train has now moved past the bridge, right? So this is the train. So if you analyze the initial position of train, it was here. And the train has moved this far. So what happened is the train has moved this much distance. So I'll make this O and let us choose say Y and this to be X. So the distance traveled by the train, I repeat, the distance traveled by the train is basically OY, right? So OY is this distance, this complete distance. Now what is OY? OY is OX plus OY. What is OX? OLXT, which is OX is length of train. What is XY? XY is this value here, which corresponds to B, which is length of bridge. So what is OY is equal to? OY is equal to LT plus LB. What is OY? OY is the distance traveled by the train. So distance traveled by the train is length of train plus length of bridge. I think now it becomes more clear to understand. If it is not, please do mention it. I'll make sure that I present a better better diagram with a more conceptual understanding.